Hello friends, if you look at the question, you could see that there's no real number for A that can help solve this problem. So we can say that A has no real solutions. Okay, because there's no number you're going to raise 1 to that is in the real field that is going to give you 100. Next, we're going to look into the complex field to see if there's a complex number A that will be able to solve this problem. And that's going to lead us to the Euler's formula, okay? Euler's formula, okay? Which states that exponential ix is simply cos x plus I sine x, okay? And if we say let x be equals to 0, we have that exponential 0 is simply cosine 0 plus I sine 0, okay? And exponential 0 is 1, cosine 0 is 1, but sine 0 is 0. So this is good, okay? But then instead of using e to the power of 0, we're going to use a more robust Euler formula for our 1. So for a much robust Euler formula, instead of e to the power of 0, we say let x be equals to 2 pi n, where n is -1, 0, 1, 2, where n is just integers and 0, okay? That's the values of n. So let's put it here. So we have that exponential I x. This is going to give us exponential I 2 pi n, okay? So let's try different values of n. If n is -1, we're going to have exponential I 2 pi, and this is simply cosine -2 pi minus I sine 2 pi, okay? And we know that cosine of a negative degree is same as the cosine of that positive degree. So this is simply cosine 2 pi minus I sine 2 pi, okay? And cosine 2 pi is 1 and sine 2 pi is 0, okay? And this is still going to give us 1. Let's say when n is 0. If n is 0, we already solved that this would be e to the power of 0, and this is 1. Let's say when n is 2, if n is equals to 2, we'll have exponential I 4 pi, and this is cosine 4 pi plus I sine 4 pi, and cosine 4 pi is simply 1, sine 4 pi is 0, and this is 1. So clearly we can say that 1 is equals to exponential I 2 pi n, where n is just integers, okay, and 0, okay? And this works. So substituting exponential I 2 pi n for 1 in the problem, we're going to have that 1 to the power of a is simply going to be exponential I 2 pi n a, and this is 100, okay? So let me write it out here. Exponential I 2 pi n a is equals to 100. Let's take natural log of both sides. Natural log of exponential I 2 pi n a, this is natural log of 100. And we know that natural log of exponential of any term, say y, is simply y, okay? So if we apply this here, which means that this is just going to give us I 2 pi n a, and this is simply natural log of 100. And if we divide both sides by I 2 pi n over I 2 pi n, we will recover that our A is simply natural log of 100 all over I 2 pi n, okay, where our n is -2, -1, 0, 1, all the way to the positive integers. But if you look at this critically, if n is 0, then denominator is gonna be 0, and this is gonna result to an undefined thing for our A. So for that reason, we are gonna cancel out 0, and our n is just gonna be simply integers, both positive and negative, but not 0. And this solves our problem, and this is the solution for A. Thank you very much, guys. Please give a thumbs up and drop a comment if you have any question.